All right, y'all, we are reviewing a little bit of our old topics of SOHCAHTOA as well as the Pythagorean Theorem. I trust that you already know this, but you may not quite remember exactly what it's about. So we are going to review that real quick before jumping in and using everything on um, on Thursday. So this is also specifically, I guess not technically specifically, but this is also more intentional towards eighth period, since it will be an asynchronous day for you. When you watch this, please make sure that you watch this and you understand what we're doing. There will be no homework for this week. This is the last week of quarter three, so please make sure to get things turned in as soon as you can. The last day of the quarter is Thursday, last instructional day. The last couple of assignments. So we have total 16 homeworks, as well as a formative assessment that is technically due on the Wednesday. Thursday doesn't really matter, I guess. Just get it turned in. Now, for SOHCAHTOA or sine, cosine, and tangent, you will need a calculator. So please make sure to have that handy, whether on your phone as a physical copy or Desmos. All those are okay. Now, Pythagorean theorem, in case you forgot, is going to be a squared plus b squared equals to c squared, where a and b are the legs of the triangle and c is the hypotenuse. So if I were to solve this, right, this is a leg, this is a leg, this is my hypotenuse. I would do x squared plus 10 squared is equal to 26 squared. Simplify what I can. No, 676. Subtract 100 from both sides to get 576. Take the square root. X gives you 24. Now, technically, mathematically speaking, you get plus or minus 24, but obviously with a triangle, you can't have a negative side, right? So we have positive 24 as our answer. Now, if you don't remember SOHCAHTOA is just an acronym to help us remember what does each trig function tell us. So for example, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, we always need to look at where we're looking from. Where are we kind of like anchored in, right? Because here, my theta is this guy. It is angle A. Because it's angle A, opposite is, well, let me just start with hypotenuse. We always know hypotenuse is the side that is the longest or opposite from my right angle. Therefore, the side that's adjacent is the one that touches the angle, right? So my hypotenuse and adjacent side forms my angle that I have here. Right? This is my angle. The opposite side is the side that is directly across, that's not touching the angle. Meaning sine in this case, opposite over hypotenuse is A over C. Cosine is B over C. Tangent is A over B. Now, obviously, this only applies to this particular triangle. We're going to look at some more examples later. Just to kind of help us practice which side is opposite. The side opposite of A is going to either be CB or you can call it BC. It doesn't really matter, right? That's this side right here. Opposite is over here. If I'm looking opposite of B, B is this here, and opposite is going to be this side, which is AC or CA, doesn't matter. And the last one is from angle C. Now, angle C is a right angle. The opposite side is either AB or BA. Oops. Now, as we're solving for these and using trig functions, I think it's important for us just to label, label is also important, but just to write down SOHCAHTOA, help us remember which one does each trig function use. Now, we are currently using degree mode in our calculator, so make sure to have it in degree mode. You can change degree mode on Desmos quite easily. On Desmos, I would click on Math Tools, Scientific Calculator, And by default, I believe it is on degree mode here. If you want to change to radians, you just click it, you go back to radians. Click it again, you go back to degree. Now, on your calculator, whether it's your phone app or a physical copy, next to second, there's a little button that says mode. You want to click on that and make sure degree is highlighted. Having said that, I would definitely start with the angle that you have, find your hypotenuse. So in this case, 18 is my hypotenuse. Now, that means the other side that's touching is adjacent. The one that's not touching, or the last side, must be opposite. So if I want to solve for x, I know opposite is x, 18 is hypotenuse, that's sine. So sine of the angle, 40, is equal to opposite x over 18. Multiply 18 on both sides, and put this in your calculator to find x is equal to 11.6. And similarly, to solve for y, I look at, okay, I have adjacent, I have hypotenuse, I'm going to use cosine. Cosine of 40 is equal to y over 18. Y is my adjacent value, 18 is my hypotenuse value. Multiply 18 on both sides once again, and find your value is y is 13.8. Okay, now, you can also, now I would also say you're given the 18, you're given this value for the hypotenuse, use it for both. Don't solve for x and then try and solve for y using tangent. That's not wrong to do, but what if you made a mistake on x? What if there was a mistake somewhere? Right? You looked at it wrong, instead of writing down 18, you wrote 19 or something. Right? Then this is wrong. Then you bring this error into this guy, then it's wrong again. Right? So I would rather you start anew, use a number that they gave you, 18, and then solve for your other missing side. All right, similarly, the second one, I want to take a look at what I am given first. From 62, my hypotenuse is over here, is x. The one that's touching is the adjacent, and the one that's not touching it is the opposite. So if I want to solve for x first, again, I'm looking at, okay, I have opposite, I have hypotenuse. That tells me I have sine. Sine of 62 is equal to 14 over x. Now, this is a little bit different because I want to make sure x is in the numerator so I can actually solve for it. So I'm going to multiply by x on both sides to get rid of the denominator x. Now, a lot of students get kind of scared at this because you're like, oh, wow, sine of 62, what the heck is that? Sine of 62 is just a number. It's just like square root of 3, just like square root of 5, just like pi, it's just a number. So you can divide by sine of 62 on both sides and solve for x. Now that I have x, let's solve for y. Again, opposite, adjacent, that's tangent. So tangent of 62 is equal to 14, which is my opposite. Y is my adjacent. Multiply both sides by y to get it in the numerator. Divide by tan of 62 because it's just a number. Then I get a answer. Okay, now here's the other thing. Make sure that you always have your trig function, whether it's sine, cosine, tangent of an angle is equal to a ratio. Now later we're going to see when I work with inverses, inverse tan, inverse sine, inverse cosine, you're going to see the inverse is an inverse of a ratio gives us an angle. And the reason is, right, they are inverses, meaning they undo each other. They undo each other, right? So if I want an angle, I gotta take the inverse of the ratio to get back an angle. Okay, we're gonna see that more later. So let's set up a couple of these. Again, SOHCAHTOA, just on the top of the page, help me to remember what I'm looking at. After that, go to your triangle. What's given to you? 53. Where's my hypotenuse? The hypotenuse is 7. It forms the angle between the hypotenuse and the adjacent side. So this is adjacent. Opposite's not touching. From here, I can see that if I want to solve for y, opposite hypotenuse, that's going to be sine. So sine of 53 is equal to y over 7. So 7 sine of 53 is equal to y. 7 sine of 53, that's 5.6. 5.6 over y. If I were something for x, it's adjacent and hypotenuse. So adjacent and hypotenuse is cosine. X over 7. Again, multiply by 7 on both sides. 7 cosine of 53 is equal to x. 4.2. Now, if I wanted to, I can use Pythagorean Theorem to check my answer. Is 5.6 squared plus 4.2 squared equal to 49? And you will find that it actually is. Should probably box both of my answers, not just one. Okay, I'll do one more of these examples so you can kind of see what my thought process is. I'm going to again write down SOHCAHTOA to help myself. SOHCAHTOA. Remind myself, from 30, label my hypotenuse, label my adjacent because it's the one immediately touching, and the opposite side is the one that's not touching, the last side. Again, if I want to solve for my hypotenuse, sine is opposite and hypotenuse, so that's what I'm going to use. So sine of 30 is equal to 9.2 over z. Multiply by my variable to get rid of it, or to put in the numerator rather. Z sine of 30 equals to 9.2. Divide by sine of 30. Z then is equal to 18.4. Okay, 9.2 divided by sine of 30, 18.4. If I want to solve for x, that's adjacent and opposite. So that's going to give me tangent. So tangent 30 is equal to 9.2 over x. Multiply by x to get in the numerator. Divide by tan of 30. So 9.2 divided by tan of 30, 15.9. Awesome. I'm going to go ahead and skip this next one for now because it's kind of the same thing. I can come back. Well, I'll just do it. Why not? So again, write down SOHCAHTOA. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. From my angle, what is equal to what, or what side is what relative to this angle? Again, hypotenuse never changes, so let's write that down first. The side that's also touching it is going to be the adjacent. Opposite is on the other side. Let's solve for adjacent first this time. Why not? Switch it up. So adjacent and opposite, that's tangent. So tangent of 67 is equal to 21.6 over x, times x times x. X tangent of 67 is equal to 21.6. Divide both sides by tangent of 67. Therefore, x is equal to 21.6 divided by the tangent of 67. 9.2. Now let's solve for z. Again, let's not use what we solved for, but rather what's given. So opposite hypotenuse is sine. Sine of 67 is equal to 21.6 over z. Again, multiply by z to get it in the numerator. Divide both sides by sine of 67. Z then is equal, wow, 21.6 sine of 67. 23.5. Now, just because we're doing trig doesn't mean we always have to calculate something necessarily. Actually, sorry, let's not go there just yet. This is a word problem, but it's pretty straightforward, right? It talks about we're 120 meters away from the building. Serena measures the angle of elevation is 41 degrees. What is the height? So from this angle, this is my adjacent. This is my opposite. So I know I got to use tangent. So tangent of 41, y over 120, multiply by 120 on both sides. So 120 times the tangent of 41 gives me 104 because it asks for the nearest meter. Equals to y, okay? So this one was pretty easy. That's why we just want to quickly do that. Now, we do want to really make sure we look at which angle we're starting from. This one says angle P. P is over here. Not only so, it just asks for the ratios. So what that means is I do not need to go above and beyond and try and calculate the decimals or anything. It's just asking for what the ratio is. There's nothing for me to put in the calculator, nothing like that. Sine of P, I know that this is opposite. This is hypotenuse. This is my adjacent. Sine is 15 over 17. Cosine is 8 over 17. Tangent is 15 over 8. And that's it. That's it. It's not asking for anything else. It's just looking for the ratios. But again, like I said, it is very important that we look at which angle we're starting from. Sine, cosine, tangent of S is here. This is the angle we start with. So sine is 7 over the square root of 65. Cosine is 4 over the square root of 65. Tangent is 7 over 4. But if we are looking at sine or cosine of r, so I'm sorry, sine, cosine, tangent of r is over here. So our perspective is a little different. So our numbers are going to come out a little bit different too. My sine of r is now 4 over the square root of 65. My cosine is 7 over the square root of 65. My tangent is 4 over 7. But notice that all these numbers are pretty much repeated, which should make sense because the only thing that's different is my opposite and adjacent switch parts, switch places, but that's it. Now, these are all just more practice. If you want to try them out, you may. I don't think there's too much of an issue here. It should be pretty straightforward. I'm going to jump to solving with word problem, but this also has an angle involved. So during its approach to Earth, the space shuttle's glide angle changes. It tells us the glide angle is right here. When the space shuttle altitude is about 15.7, which is right here, that's my height. Its horizontal distance to the runway is about 59. So that's 59 down here, 59 miles. That's this guy right here. Ugh. Okay, that's what it's talking about. What is its angle? So we haven't really worked on this today yet, but you did do this in geometry. Again, just to make sure this is my angle. That means this is adjacent because it's touching it. The height is going to be the opposite. So I'm going to use tangent, meaning tangent theta is equal to opposite 15.7 over 59. But how do you solve for an angle? Well, remember that if I have a tangent or sine or cosine of an angle, that gives me a ratio, but this is where I would use the inverse, because the inverse of a ratio inverse trig of a ratio will give me back an angle. So I'm going to rewrite this as inverse tan, or I guess another way you can think about this is I'm taking the inverse operation. So I can take the inverse tan on both sides. So that I'm left with this will cancel each other out, where I have just theta is equal to inverse tan of 15.7 over 59. Inverse tan is under function for Desmos. 15.9 over 59 gives me 15.1. Is that right? Inverse tan, oh, 15.7, okay. Whoops, 14.9, sorry. Now, on your calculator, you do need to click on second, and then either sine, cosine, tangent. You'll see above sine, cosine, tangent, there's a little yellow version of sine, inverse cosine, inverse tangent. This last question kind of puts everything we know kind of in one mixed bag here. During a flight, hot air balloon is observed by two persons sitting at A and B. The angle of elevation of point A is 28, so this is 28 over here. Point A is 1.8 miles from the ground to the balloon. So 1.8 miles is here. What is the height? We can see this is the adjacent side. This is the opposite side. This is going to be tangent of 28 is equal to h over 1.8. Now I know this can be confusing because in this case, h stands for height, not hypotenuse. You just have to be careful about what each of your letters mean. So 1.8 tangent of 28 is 1. It's just the nearest tenth. Oh no, nearest tenth is 1. So 1 mile is equal to my h. They give us a little more information. They tell us from B to A is 2.9. That means B to the balloon is 1.1. And they want to find this angle measurement. Well, for this triangle from where B is, 1.1 is the adjacent. H is still the opposite. So I can still use tangent. Theta is equal to, now this time I know what it is, 1 over 1.1. Now this time we had to use a calculator value. That's the purpose, right? That's how they designed it to be. So I'm going to take the inverse on both sides. This is going to cancel. Theta is equal to inverse tangent of 1 over 1.1. So inverse tan, 1 divided by 1.1. Okay. 42.3. So theta is equal to 42.3 degrees. Whoops. And that's it. Okay, I hope that makes sense. Please ask questions. If you do have questions, feel free to email me. I am more than happy to answer any questions you may have.